Although Minecraft is proprietary software and these days I would like to refrain from making videos and content about proprietary software, I will make exceptions where I deem it reasonable. In this case, I've made these sorts of creations with the Minecraft mod buildcraft. These are memory cells, and I will be showing you. In the previous video I think I already showed this one, the one-time read memory cell. It basically just reads those signals from there and then sends the wires. And then like there's this like and then it does that. So like if I do that, that's writing it. And then like I can read once more. But that thing clears it so it doesn't work anymore. That's a pretty useless thing. But I've made some actual useful memory cells also. Yeah, so I'll be going through all of these things. So this thing saves it and then read. I can read it as many times as I want to. I'll basically just go through these options. So there's that one. These ones, I'm not sure if I need to show them. Actually no, I will. So the blue one goes there and the red one goes there. The red one also comes here and blue one goes there and yellow one goes here. These are the same as always. Now here if those do then that. So if the blue comes in and the yellow there, then it sends the, what was the color, green signal there, here. This of course can be stacked, this design. And I believe the one, actually no, I don't think I have any stacked version of this, but yeah, this design can basically just be stacked. This is a different design. I've also laid out the dimensions in here in the, or like mentioned them. So like here's a stacked version of like a memory cell. No, that's a different one. So like if I like write this number, let's say, and then there's like all these addresses, I'll write it to, let's say, that address. I've now written it to that address, and then I can turn this off. And then if I read from this address, it outputs the same one. I don't know what these others might have. I guess they don't have anything. But I could of course store different numbers on different ones, so if I put these on, save that there, and then I put these ones on like so, and save that there. Now I've got this one, and this one is still clear, so I will also put some stuff there too. Something interesting, save from there. So now if I read from there, it also has that number. So this basically memory. Now it's lagging quite a lot, the frame rate is not the best one. Yeah, right, so let's see if there's like a good place to look at it from. Let's see, so yeah, of course this is usual. So the green wire, it basically goes through all of these, and then it goes up one level. Then there's the blue ones, this is the one that saves the signal, it goes here and it goes to all of these, like so. Then there's the internal yellow one. Let's see if I can try to show it to you. It's a bit difficult to see through this thing. I don't see, yeah, I don't have any other copies of this. I don't wanna destroy it either. Anyway, so yeah, let's just show this content too. This is the logic. Then the yellow one, it goes up there, and then you can see that on that side. Here's the logic here. Then there's the green signal finally. The green signal then is the one that outputs and then brings it here. So it's the same design duplicated. This is a stackable cell design. It's the same one. So if you look at it there, like yeah, so all of the sides are like basically equivalent to each other. Now I guess these sides might not have the, yeah, these plugs are not at the, wait no, I'm not sure if I have the, yeah, I don't have the plugs here on this layer. Yeah, the blocks that are there, these blocks are missing here. But if you look at this side, it's starting to get to night apparently. So yeah, right, so things. That's a neat memory design, but that's not the most optimized design. As you can see there, the number, it says 142, so that's like 8. 8 is like that's the volume, the size of it. Here's a design that's only 222. But that's still 8. Here's a neat one. This is 1 times 7 times 1. I guess I could still take a look at this. Wait, yeah, that's a different one. I could also show you this one too. This is a cube shape cell. That's a pretty neat looking thing, isn't it? So yeah, like it's a cell, and I'll show you the logic. That has this kind of thing at the top here, yeah. Then this thing has blue one, yeah, red one. But any other logic? There, that one. And these designs are all stackable. I don't think it has any other gates. But yeah, this is a nice one because it's only 7 in volume. It's really tall too, so it's pretty compact. Like each one block is its own cell, looking from the top down. Alright, so if I just go through it, I'll show you the way it works. There's the yellows, another red one. Then on the other side I can show you the blue ones and the green ones. There's the green ones and another green one. And there's a blue one and another blue one. And then also the blue ones and the also the blue ones, they go all the way that way, and here the red ones, they go all the way that way. Right, and then the logic is of course always the same. Yellows, greens, and yeah, it's always the same. And then this one is just yellow and green to make the red one, and then the red one goes out there. Of course I don't have any outputs here, but basically the way the outputs would work is just the same as here, so it just makes it like that. So then the outputs would come out. So yeah, that's a memory cell design. But that's still not the best one. The best one is this one. You can see that the dimensions here, this is very small. It's only 6 blocks in volume. Oh yes, and also I numbered the amount of gates also. So 2 gates, 3 gates. I don't think I mentioned there how many gates there are. But yeah, so like the size and the number of gates. The number of gates of course means how fast or slow it is. This is by far the most optimal design, and I haven't figured out any other better ways to make this any more compact. This is the best design. This is by the way the same as that one. That's just a bigger stacking of this same design here. So I will show you this one. Right, so I was using the world edit mod to duplicate these designs, so that's why this thing is embedded into the ground. I just copy pasted it here poorly. But if I show you, like, here's the blue signal goes in this direction, and it does so in all of them. The blue of course doesn't connect from one to another, of course, as always. Then there's a red one that goes this way. And of course these they don't connect. The left one doesn't connect to the right one, the red ones. Right, you can see the green ones. The green ones connect this way, as well as the blue ones, of course. The yellows only go up. And then the logic gates, or pipe gates, whatever these are called. No, they're just called gates. Okay, so there's the logic, and then here's the logic on the upper one. It only has these 2 gates, and this is the most efficient and compact design that I've come up with. I'm not sure if there are better ways to make this. There might not be. Anyway, yeah, that's the design I came up with, and then I made this massive stack of it. The frame rate is starting to go down significantly. The frame rate suffers a lot when displaying lots of these pipe wires. So So yeah, the design is here, of course, what I just showed you. So it's the same on the blues, and the greens go horizontally and the red ones go vertically, looking at it from this direction. Oh, and also there's the red one underneath too. So there's red at the top and red at the bottom. They both go that way. This is the output, the higher one, the one above. And then the inputs are, of course, the ones at the lower. And of course the inputs always work that way. I've also made this here that is like an example of like reading it. So let's see, I apparently already have something written there. So you can see these yellows that are highlighted, that's like already written in there. So let's see, which one was it? The one that reads the numbers. Green one reads. Okay, so let's hit the green one. And this is what happens when it's read from the memory. So apparently I've stored this number there. So of course now if I write something else, put those on like so, and then blue saves. Now you can see that the number that is highlighted in there is different because it stores that number there. And now of course if I read it with the green one, it's this number. And that of course is the exact same for all of these. I only have this connected to this one wire here. So you can see the green ones and the blue ones as they go all the way there. I've only connected this one thing, and here I had a test one. So like I can store another number there. So if I disconnect that, add the green one and the blue one there. Now I can store a different number to the other address. So blue one saves. Then I can turn this off. Oh, and by the way, it doesn't matter if I also have it on, like I can have those on at the same time as I read it. It just doesn't read the same number. So yeah, now it's also reading that thing. So yeah, just to demonstrate that it doesn't interfere with the other, so like I can do whatever here that's irrelevant. But yeah, just to show that it retains too, so yeah. So that's why I turned them off. So yeah, that's a memory cell. Now you can see that the two numbers are still like visible in there, because the yellows are highlighted when they are storing the number, and this of course extends to as far as you can take it, and like there's no theoretical limit, at least from the design's point of view, on how big this can be. As you can see, this is 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 bits wide, so like that could be the word length. If you have RAM on a computer, then this is 1 byte. Basically, that's like that's also the word length here. And I don't know how many numbers this is, and I don't care to count, but yeah, it can theoretically go as far that way as you want it, and it can be as many wide as you want it, so there's no limit to that. I'm not sure if this can be stacked on top of each other, so like duplicating this exactly on top of itself. I would need to look into that. Let's see. I suppose it can be. I guess it does. Like you would just need to add the plugs. But what were they called? The plug. Yeah, the pipe plug. You would just need to add the plugs at the top like this. So this way, when the plugs are at the top, you can then duplicate this exact design and put them on top of each other, and you can stack a big amount of RAM like that. I don't really know if there's any useful application for these. I really just did this as a kind of a novelty project, just for the experimentation of itself. So like it's just for the sake of itself, just to see if I could do it and how compact I could make it. But I don't know if this is useful to someone, then whatever. But yeah, so that's why I'm sharing this, because the time and energy I spent creating these designs, well, I might as well share these with someone, because I probably won't find any use case for this. So if I share this with the world, maybe someone will, or maybe it's just something interesting to look at. In any case, so yeah, I just decided to share this. Otherwise it would be kind of a waste, in some sense. But yeah, that's memory cells. Now of course it wasn't a waste in the sense that like it was interesting enough for me to work on it. But yeah. Right, so that's lots of different memory cells. This one is almost as good as that one. It's just 1 byte, 1 block bigger, but it's the same amount of gates. So yeah, this design isn't that good because it has 3 gates, so that makes it slower and less efficient. So did I show all of the gates? 1, 2, 3. Apparently the number of gates isn't mentioned here, so I need to count that. Let's just take a look at it quickly, if I can count them correctly. Let's see, there's 1 gate, 2 gates. So I guess that's 2 gates then, because there's 1 gate there and another gate there, so I don't think there are any other gates. So I guess this is 2 gates then. So other than being just a bigger cell in terms of volume, this is actually pretty good too, because it has 2 gates, just like that one has. So if the size isn't really that much of a concern, then it doesn't really matter. I just wanted to push it as far as I could take it, so this is the most optimal design, the most compact. So yeah, that's that for this video. Thanks for watching. Until next time, bye.